All right, here we go. It says P of xy is an arbitrary point on the line x minus 3y equals 5. And then we're asked to express the distance d from the origin to P as a function of the y coordinate of P. And so essentially what we got is just some point off somewhere, who knows where it's at. And we're trying to figure out what is the distance from the point to the origin. And it can be anywhere. It's just arbitrarily x and y is given as its xy coordinates, and we're going to be writing it in terms of y. So here we go. Now, distance itself is equal to the square root of your x values subtracted, so x1 minus x2 squared. Let me give it a little more room. X1 minus x2 squared plus y1 minus y2 squared. And that really comes from the Pythagorean theorem that if we were to square both sides, we really have c squared equals a squared plus b squared. So keep in mind that that's really where distance formula came from. And if you forgot the distance formula, you could always recreate it by doing the Pythagorean theorem of here's our a, here's our b, here's our c. So a squared plus b squared equals c squared. And c just happens to be actually called d here because it's distance. All right, that all being said, let's go ahead and work our way through. So we know that one of the points, we know that the origin is at 0, 0. And so we can plug that in as an x and y value. So we have now distance is equal to the square root of x, and we can call it x, well, actually we do know the other point, it's xy. So we can substitute in all 4 points. We got x as my x value, minus 0, that's the origin x value, squared, plus y, that's the arbitrary points y value, minus 0 squared, because 0 again is the y value of the origin, and that is in actuality just distance equals the square root of x squared plus y squared. And so we're off to a good start here. X squared plus y squared, the square root of that is equal to the distance. Now, we're asked to write the function write the function for p as a function of the y coordinate. So we need to come back to our equation of the line here, and we need to do something to get rid of the x back in our square root. And so to do that, we're going to take this equation, solve for x, and then substitute that in to get rid of that x variable. And hopefully you can see here that if we were to add 3y to both sides, we'd end up with x equals 3y plus 5. And now we've got our new x value that we're going to substitute in. So coming on back, we've got distance is equal to the square root of, well, instead of x, we're going to plug in 3y plus 5. Now that quantity squared plus y squared. The y squared didn't change. And now we've got it really in terms of y. It's p as a function of the y coordinate. The x variable is gone. But let's still clean this up a bit. And so remember 3y plus 5 squared. Going to distribute that out, double distribution. So 3y plus 5 times 3y plus 5. And we're going to end up with d is equal to the square root of, what's 9y squared plus 15y plus 15y, so plus 30y, and then plus 25 plus y squared. It's really that plus y squared. Let's go ahead and just slide it back in. That y squared plus the 9 we had is 10y squared. So there's our final answer. The distance is equal to the square root of 10y squared plus 30y plus 25. And I suppose if we're writing this as a function of y, let's go back and write it as d of y. All right. Hope that helped.